Okay, where did we stop last class? What happened to you? You're becoming quite irregular. Okay. So are you following all the lectures on video? You have done completed. Where did we stop last lecture? We have done we completed the exercise for transformer and all that chapter, right? We already started calorimetry. So what have we done in calorimetry? So what have we done? We have seen that changing temperature in Kelvin is equal to change in temperature in degrees Celsius. Then what did we do? Thermal capacity or heat capacity. We did this. How it is given? So thermal capacity is amount of heat needed to raise the temperature of body by 1 degree Celsius. Okay, that's what is thermal capacity. And what is specific heat capacity? You have to tell me where did we stop? Did we do this? Okay. So this, let me just write it, specific heat capacity. This was same thing per unit mass. Same thing per unit mass. Okay. And then we also did principle of calorimetry, which is heat lost is equal to heat gain. Okay. Where what is the formula for heat? Or U is equal to delta vector. This is the formula for heat from here. Okay. So we have done all this and we have also done calorimetry. Now we have to discuss the consequences of high specific heat of water. So anybody remembers what is the specific heat of water? One. 4200. Oh my God. Okay, so you have to tell me.
She told me that we have to start from your side.
You attended last lecture?
Yes.
Okay. So this is all part A. So we have completed this. So unit B में, okay, ठीक है. So we did all this. We have done all this, right? So what is the formula summary for unit B? This is unit A. So what we have done just now is formula summary for unit A. What is the formula in unit B? Only one formula, which is Specific latent heat. What is it? Specific latent heat. Specific latent. So this is the last topic, right? Do we have any topics left after this? Okay, we have one more. So we have, what is the formula? L is equal to Q by M. Right? There is no change of temperature whenever heat is absorbed during change of phase. Right? Anybody still remaining to sign the attendance sheet? So here, yes. So whenever phase change is involved, the formula for heat used is to be M into L. Mass into, what is L? Specific latent heat. Okay? And whenever there is rise in temperature involved, rise or fall in temperature involved, that time you have to use the specific heat formula for heat. Okay? So for phase change, specific latent heat formula for heat, and for change in temperature of the body, specific heat formula has to be used. Now keep this in mind because most of the mistakes happens in selecting the formula. Okay? Walk in. Come fast. So let's go for the consequences of high specific latent heat of ice. Somebody give me the. We discussed the effect of impurities on boiling point and all. Okay, last one. So everybody go on page number 293, Selina. So any idea what is the latent heat of fusion of ice? Huh? What is latent heat of fusion of ice? Latent heat, specific heat of water is 4200, whereas latent heat of fusion of ice is 2100. That is specific heat. That is no latent. I am asking latent heat of it. It's 336 joule per kg. There is no temperature involved. So a lot of heat is required to melt 1 kg of ice. If you are trying to melt 1 kg of ice into water at 0 degree, how much heat is required? 336,000 joules. Much larger than heat needed to raise the temperature of water by 1 degree. Is that clear? So it is much large. Same thing will become 336 joule per gram. Okay. So what is the consequence? Can you tell me how much heat will be released when 1 kg of ice is frozen into water? Did you get the question? How much heat will be released when 1 kg of ice or 1 kg of water is frozen into ice? Same thing. Okay, it's the same thing. So it is latent heat of fusion as well as latent heat of melting. But we just say fusion because both are same. Okay. So having known this, the first point is snow on mountains does not melt all at once. Snow on mountains does not melt all at once. Why? What is the answer? Snow on mountains does not melt all at once. Why? Yes? Yes, Akhilesh? क्यों नहीं मेल्ट होता है एक साथ? क्योंकि मेल्टिंग के लिए बहुत ज्यादा हीट चाहिए. अगर 1 kg आइस को मेल्ट करना है तो इतना जूल्स ऑफ एनर्जी चाहिए. तो एटमॉस्फेयर से बहुत एनर्जी इट विल एब्जॉर्ब. ठीक है? सो आंसर क्या लिखोगे? This is because high specific latent heat of ice. इसलिए a lot of heat is required to melt a kg of ice. All the questions I am going to ask, answer is same. High specific latent heat of ice or high latent heat of fusion for ice. बहुत एनर्जी चाहिए इसलिए. So is it a good thing or a bad thing? It's a good thing. What if all the ice melted at once? There will be flood in the region around. Okay, and the source of fresh water also will be lost. I mean, during rainy season, lot of water rains, but do we accumulate it for drinking? No, it just goes away. So just like that, if all of ice melted all at once, the source of fresh water will just disappear. So it is good. Here around we have a stream of water which flows slowly. Okay? Because of very high specific latent heat of ice. So for melting, lot of heat. For freezing, also lot of heat. So during melting, lot of heat is required by ice. During freezing, the heat will be released back into atmosphere. Okay? So just remember this. Next, what is next? In cold countries, water in lakes and ponds does not freeze all at once. How do you explain this? Okay, all the water in lakes. All at once. Why? Why? Same answer. So let's say you have a lake. Let's say the atmospheric pressure is dipping. Okay, so what will happen? Let us say atmospheric pressure goes 0. So what happens now? Explain the freezing. What happens? Let us say initially the temperature was 5 degree. So whole of water will be at 5 degree. Correct? Now it is dipped to 0 degree. Then explain what happens. Somebody stand up and explain. Chalo, just get up. Yes. What has happened is, everybody pay attention now, because next I will be asking somebody from this side. So initially the atmospheric temperature was 5 degrees Celsius. And at that time, all of water in the pond was at 5 degrees Celsius. Full. Now the atmospheric temperature has dipped to 0 degree. So explain how the freezing of this will take place.
The top level becomes 0 plus slowly the water will circulate.
So top level becomes 0 degree. Will it be 0 degree water or 0 degree ice?
0 degree.
0 degree ice? 0 degree water. So then what happens?
Then the water will circulate because the
Yes.
density of water.
Because the density increases, and therefore this low density water will replace. And this cycle will continue till the whole water becomes 0 degrees Celsius. Okay. Then what?
It will continue till the lake doesn't become 0.
And while it is freezing, it is releasing how much heat?
4.4 pounds.
So when the water is freezing, it is now releasing heat. Okay. Back in the atmosphere. So when the freezing is taking place, right, it is releasing heat back to the atmosphere. Okay. Now, what next?
It will continue till the whole lake doesn't reach 0.
So now the upper layer will become ice. Now ice is a good conductor or bad conductor? It is bad conductor also. Okay. So only some part of it, all the water in the lake will not freeze. Only the top layer will freeze. Okay. Till there is no conduction possible to the other part. So this part will remain at 4 degrees Celsius. ठीक है ना? तो सारे का सारा तो 0 डिग्री होगा भी नहीं. So is it a good thing or a bad thing? Good thing, because all the aquatic life survives during the cold weather. Okay, so this is what happens. Now third part, drinks get cooled more quickly by adding pieces of ice than ice cold water at 0 degrees Celsius. So this is the third part. So here some drink with ice cube added in it. So this is ice at 0 degree, and then here now you have added water at 0 degrees Celsius. Which will be more cooler drink? First one or second one? Water added at 0 degree in the drink, and this is ice at 0 degree added here. Which drink will get cooler eventually? Water at 0 degree will get cooler. One answer is no, that's not correct. Ice wala. You explain. You have to explain. Huh? So this ice will melt once it is inside the drain, correct? Ice will begin to melt, isn't it? So ice will actually absorb heat from water. From where ice will melt? Ice will absorb heat from water. After absorbing 336 joule per gram, whole of ice will melt. It will melt to 0 degree water. Means after absorbing this much additional heat, now it has reached a state where when directly water at 0 degrees added. Okay, so here this much additional heat is absorbed. Now here the 0 degree water absorbs heat and its temperature rises. Let us say the drink was at 25 degrees Celsius. You have added water at 0 degree. Now when it absorbs temperature, somewhere the normal temperature will be somewhere around say 15 degrees Celsius. Isn't it? Whereas this will be at a much lower temperature than 15 degrees because it is now absorbing more heat. Okay, is that clear? So ice is absorbing additional heat during melting, and after melting this has reached this stage. Okay, is that clear? So this is what it is. So this will be more cool. Will be produced here. Okay. When ice in frozen lake starts melting, its surrounding becomes very cold. Has to be that way, right? Because it will suck heat from atmosphere. So when the day when it is snowing, that day it is not very cold. Cold starts when the snow begins to melt. Okay? Because now it is sucking heat from atmosphere. Okay? Now, the fifth one, what is it? Same thing. Fourth and fifth are the same thing. Instead of snow, it is hailstorm. So in hailstorm, what you get is hard ice pieces. Okay? So hailstorm, when the ice melts, again the same thing. Lot of heat will be absorbed from the atmosphere. Okay. Shall we do numericals? We have done numericals from part A? No. So tell me, I mean, everybody has Selena? Each table has a Selena. Each table has Selena? Okay, let's do numericals from Selena. You don't have Selena? तो किसी टेबल पे दो सेलिना भी एक इधर उधर. It's new, right? Okay, let's do numericals from part A. This is page number 288. So even in this book, most of the numericals are from Selena. Okay? So what is which one shall we do? Odd or even? Odd or even? Shall we do even? Evens are slightly hard. Okay? Let's do even. Question 2. So what do you have to calculate here? So you have to calculate heat capacity of copper vessel of mass, given mass, and you have to calculate this is what you have to calculate. So solution. So by formula of specific heat, what do we have? Heat absorbed per unit mass per unit rising temperature. This is the formula of specific heat. So we will use it for specific heat of copper. And what is this? Q by delta T. Okay? Q by delta T is nothing but heat capacity. In this question, we have to find heat capacity, right? So therefore, heat capacity is what? Therefore, C dash is M specific heat of copper. So mass is basically, so you have to make sure that this mass and this unit of kg per gram has to be same. So you can make 0.2 kg. Either you make 0.2 kg or this you can make, what can you make here? 0.410, 0.41, okay? So this becomes 0.2. So this is 82, okay, joules per. This is the answer. Either joules per Kelvin or joules per degree Celsius. You can write any unit. Okay, both are same. Now what you have to find in the B part? How much heat energy will be required to increase the temperature of the vessel in part A? So given delta T is equal to so what is the rising temperature? You have to find how much heat is needed. So you already have heat capacity. So since C dash you calculated was 82. Okay, since you had already calculated heat capacity, for testing, just keep the bags away. Keep it there. Bottle inside all passage. Which question? What about the other question? Oh, you're doing part B. Selena, immediately. Okay, everyone try question 4. I've already given you the formula summary. Second one, समझ आ गई? Read the question and then see what you are doing. Try question 4. Let me see if we have it in the volume. Your classwork question 1 is exactly similar, just the values are different. Okay, those who don't have Selena, like they can try questions from their volume. Shall I do question from volume then? Everybody has volume? Huh? Each one of you have volume. Say yes or no. Shall I do it from Selena then? I mean, volume. Everybody has volume?
Yes.
Okay, let's do it from volume. There are a lot of them who don't have Selena. And there are some difficult questions in Selena. I will take that up separately. Okay. So question 1 is exactly same what I have done here. So volume, liquid volume. Page 103. Everything is same. Now mass becomes how much? 150 grams. So this becomes 0.15. So this will become 61.5. Okay, and this thing will become okay, only the values might be different, questions are exactly same. Here also it is like events are arranged here. Okay. So next question. Try the next question. 45 grams of water at 50 degree in a beaker is cooled and 50 grams of copper at 88 degrees Celsius added to it. Write down the given data. Second question. This table doesn't have volume. She doesn't have volume. This is question 1 of volume. Okay, let's try question 2. You have 45 grams of water. So this is a question on heat loss. So therefore, let's say heat is lost by hot body C1 F1 delta T1 equal to CS. Okay, delta T1 is T1 minus T. T2. So heat is gained by cold body. So obviously heat gained, that means T2 is smaller temperature than T1, and T is the temperature of final mixture. Okay, this is final temperature. So what do you have to calculate here? Final temperature. So just substitute the values, or you can write the formula. So final temperature will be this is what it is. So here 1 is hot body, 2 is cold body. Now substitute. Therefore T is equal to, what is the hot substance? Hot substance is water. So what is specific heat of water? 4.2 joules per gram per Kelvin. That is C1. Mass of water is 45 grams. And its temperature T1 is 50 degrees. Plus, what is the cold substance? Cold substance is copper. And copper specific heat is 0.39 joule per gram per Kelvin. And mass of copper is 50 grams. And it is at 18 degrees Celsius. Okay. Here also it is 4.2 into 45 grams plus now I have written here units is just to show you the calculation. Here per gram will get cancelled by this gram, and per Kelvin will get cancelled by Celsius, because Kelvin and Celsius are same. Okay, on the scale of Kelvin and Celsius scale, per Kelvin and per degree Celsius is same, so this will get cancelled. So here also. So what will remain? No. Yes, this is correct. And here what will get cancelled is gram and gram. Then we have this gram and gram. So what is remaining in the denominator is joules per Kelvin. And what is remaining in denominator is only joules. So in final unit calculation, it will only be Kelvin. Okay? This answer is joule. So what is it? This will be in joules divided by this will be joules per Kelvin. So finally joule and joule will get cancelled, and what you'll get is Kelvin. So this also will get cancelled. So find out how much is this. So this is 42 into How much is this? So this has slightly bigger calculator, and this will be this calculation correct? It's 9450 plus 980. So this is around 40. What is the Okay, so this is there was a mistake here. I wrote a 0 extra. So this is question number. Which question in Selena? This is also in Selena. Keep telling me. In Selena question, where does the third or fourth over? Fourth over. This is Selena question 4. So you can write it as 47 Kelvin. Okay. Is this fourth question? Selena? Okay, now next is, everybody has understood the steps? Are the steps understood? Okay, so I'll go ahead then. Next is question 6. Is it 12? Okay, ठीक है. Selena में भी ये question है. Next is calculate the amount of heat energy required to raise the temperature of 100 gram of copper. So can you do it? It is very simple. Question 3. weighted rate, and then what about T? You must have done the approximation before. When you do the approximation, minus then you get zero's approximation. One particular okay, question 3. You have to calculate the heat energy required. यहाँ पे कौन सा फॉर्मूला यूज होगा? So it is straightforward. Cm delta T. Okay, everything is given in the question. C is what is M? 100 grams. So it is 0.1 kg. What is delta T? 20 to 70, that is 50 degrees Celsius. So K will get cancelled with Celsius, kg with this. So what do you have? 39 into 50. So this was a straightforward question. You only have to calculate the heat needed to raise the temperature of copper from 20 to 70 degrees. So try question number 4. Very good question. Let me see how many of you are able to do it. This is Selena question. Which one? Time taken by a 500 water heater. Must be 7, 8. Question 7. No, what is the question? Time taken by 500 watt heater. Huh? It is 4th one, the new one. Are you doing unit A or B? For a book, same है कि अलग अलग है? This is question 7. What is your question? Question 7. That is question 3. And we are now talking about question 7. Which is here question 4. यहाँ पे question 4. Question number written on the board is from volume. Okay, just see which question it is in Selena. Okay, so how will you do this? You have to now calculate how much time it will take. So here, since Q is equal to Cm delta T, correct? But now heat is not given. What is given? What is given? The heat supplied by the heater, okay, in unit time, which is power. So what is the relation between energy and power? Energy is power into time. And you have to calculate T. So here heat is not given directly, it is given in terms of power. And what you have to calculate is time needed to raise the temperature. Okay? Because this much joules is the total heat energy required to raise the temperature to delta T from 18 to 38. So in how much time you will be able to do? Just divide that by power. Got it? You got this yourself? Very good. So it is the same thing. ठीक है, heat is not given directly, it is given in terms of power. So about T is equal to what? What is C here? C is so in volume the unit of specific heat given is wrong. What is the unit of specific heat given in volume? Joules per kg. It should be joules per kg per Kelvin or degree Celsius. So it is first is 960. Mass is 50 kg. Delta T is how much? Is 20. Power is 500. 500 watt. Watt is joules per second. So it is 19-20 seconds. If you divide by 60, you will get minutes. So this is correct as per the values given in volume. I think wait, we started 5 minutes late. We started at 5:25. Yes, 5 minutes for us. 5:25 we started. So I think these are two lectures together. एक numerical और कर लेते हैं. So this is okay. Everyone got it? This was slightly tricky. Here heat is expressed in terms of power and time. बस उतना ही. Let's do question 6. So in volume, all the first unit questions end here. Now what is starting is unit B questions, 6 onwards. Okay. So what do we have here? We have 10 gram of ice. So what is happening here? We have ice at 0 degree. Absorbs. So what is happening here? You have 10 gram of ice at 0 degree Celsius. You have 10 gram of ice at 0 degree Celsius. It is absorbing how much heat? 5460 joules. And what is it doing? First the ice is melting into water at 0 degree. Then the temperature of water is rising to 50 degrees Celsius. So how many heat components here? 2. Okay. So basically heat supplied is equal to Q1 plus Q2. What will be Q1? And Q2 will be CM pressure. So heat supplied, total heat supplied will be used first in melting the ice at 0 degree and then change that 0 degree water to 50 degree. So what will you do here? L is given in the question. So what is L? Latent heat of fusion of ice. How much is that? It's not given in the question. 336. Okay, so take that. So this is 336. So what is mass? 10 gram. This is 4.2 into 10 into delta D is 50. Oh, this you have to find out. Q is 546. You have to actually find L. Okay, in this question. So when you find L, it should be 336. Just check that. So therefore L is equal to 42 into 50. And this is how much? This is 10. Okay. So what is it now? This is 0, 6. 8 rupees 26. So this is expected answer and we get it. Okay, let's break for 5 minutes. It's a short break.